Hey guys, so in this video we're going to be talking about series. And so you're going to see, we're going to have this funky little symbol that maybe you haven't seen before, and we'll talk about what that means. And so let's just get right to it here. So summation notation is what we're learning about, and it's used to describe the sum of the terms of a sequence. And this funky little symbol is called sigma, and that's used to indicate sums. It tells you to add up, okay? So for example, on here, we have this arithmetic sequence here, a sub n equals n squared. We saw this on the last video. And this is telling us to add up the terms from 1 to 5. The letter down here that you see also in here to represent the sequence is called the index. Okay, so n is the index in this, and it's telling us to start at 1 and to go to 5. And again, this summation notation is telling us to add up all these answers. So what this would mean is, again, we have n squared. So what this would mean is start with 1 and do 1 squared. And then we're going to add to that, now go to 2, 2 squared. We're going to add to that 3 squared. Add 4 squared, and then add 5 squared, and that's where we stop. And so we're going to write what this is. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And when you add all of those up, you end up getting 55. And so this is the sum of this sequence. This expression right here, I get either written here or here, this expression is called a series. Okay? And again, we talked about the index of summation, and that's the letter n. Now it can be rewritten with different letters. You might have an I, you might have a J. Usually you see I and N in some of these videos. Those are probably the ones we'll use. I, N, and J are the ones we're going to kind of work with. So in this video, we're going to evaluate a sum in summation notation, kind of like what we just did there. We're also going to talk about, again, expressions like this. Those are called series. And again, it says the indicated sum of the terms of a sequence is called a series. This is the indicated sum. Okay, and then we'll also convert to summation notation and talk about changing the index a little bit. So let's start with example 1. So here we have, it says find the value of the expression, and it gives us a summation notation. The the index of summation is I, and it starts at 1 and it goes to 3. Here is our sequence here. And so what we're going to do is start at 1, plug in a 1, then plug in a 2, then plug in a 3, and add those together. So here we go. So if I start with 1, that would be negative 1 to the first power times 2 times 1 plus 1. All right, and then we're going to plug in a 2. So this will be negative 1 to the second power times 2 times 2 plus 1. And then the last one, because we stop at 3, will be negative 1 to the third power, and we'll be doing 2 times 3 plus 1. So let's try to figure out what these are. So negative 1 to the first power is negative 1. 2 times 2 plus 1 is 3. So this is negative 1 times 3, which is negative 3. And then we have, on this one, negative 1 squared is 1. 2 times 2 is 4, plus 1 is 5. So this is 1 times 5, so that is 5. And then the last one, negative 1 to the odd power, or third power, that's going to be another negative 1 2 times 3 is 6, plus 1 is 7. So this will be a minus 7. So negative 3 plus 5 minus 7. And that is negative 5 altogether. So that's all. You just find the value of the expression. You start at this number down here, and you end with the number on the top. Okay? So example 2, they talk about converting to summation notation. So they want you now to write it in this form. They want you to write the summation notation. So you're going to have to do a couple of things. First, we're going to have to figure out what the sequence is, writing the nth term of the sequence. And we're also going to have to know how many numbers do we have, and what number do we start off at, what do we end at. So for this one, the general form for the sequence, these are positive integers. And so remember from the last video, the positive integers we represented as 2n. So we're going to say that's, again, summation notation, because that's what this is. And 2n is how you represent the even numbers. And then if you think about where do we start? So if I do n equals 1, that's 2 times 1, that would be 2. So we do start at 1. So we're going to say that n equals 1. And then how far does it go? We've got 1, 2, 3, 4, 5, 6, 7 terms. Okay, and if we think about it, for 7, 2 times 7 is 14. So we put a 7 up here. Okay, so that's what we have to do. We have to rewrite this using summation notation. Let's try a little bit more of a difficult one. So now this next one, we have to figure out the nth term, but we also have alternating signs. And again, on the last video we talked about that. You use powers of -1. And we mentioned on here, if we do, it depends on where we start. So if we do usually a -1 to an even power gives you a +1, and a -1 to an odd power gives you a -1. And so we have to figure out, where we're going to be starting here. So one thing you can do is look at how to represent the numbers in general. So look here, we've got a 1 on the top and it alternates signs, and then we have 2, 3, 4, 5, 6, 7, all the way to 50. So we could technically write this in a couple of different ways. We could write it as n plus 1 on the bottom if we wanted to think of n as a 1, because 1 plus 1 is 2. We could do that. We could also start it as just n and then just start the count at 2. So those are a couple of ways to do that. So for our summation notation for this example, let's just use n to represent the number, and then we'll start it at 2. So we'll say n equals 2. Now if we do that, then we have to think, okay, well then how are we going to represent our -1 power? Well, we said -1 to the even power would be a +1, and that's what we want. We want the first term to be a 1, a +1/2. The next term is a negative, the next term is a positive, the next term is a negative. So if n starts as an even number, we can actually say that's -1 to the n, because starting it at an even number is what we want. We do want it to start off positive. Okay? So we can say, again, -1 to the nth power, that's going to take care of our alternating signs. And then if we just make it n on the bottom and start it at 2, start the count at 2, then we can just say, okay, yeah, that's just n starting at 2, and it'll count up to what number? 50. So we write a 50 on top. So again, that's how you would write the summation notation for that one, starting the count at 2. And then finally, it says here, in example 3, this one we just did, it says we saw the index go from 2 to 50, but this is arbitrary. A series can be written with the index starting at any given number. So again, you could rewrite this in a few ways. So we're going to look at this sequence right here, and this series. It says rewrite the series with an index j, where j starts at 0. So we could do that. So we could think, okay, it's supposed to start, because I starts at 1 and j starts at 0, you can say I is equal to j plus 1. Okay, so think about that. If j starts at 0, 0 plus 1 is 1. And remember, I starts at 1. So they're just saying you could rewrite this expression like this. That'll help us change this sequence. And so again, we have I equals j plus 1. And because I ranges from 1 to 6, it would make sense then j would have to range from 0 to 5. If you think about that, if I is 1, j is equal to 0. If I is 6, j would equal 5. It would be 5 plus 1. Okay? So when we rewrite this, we're going to start this again with j. We're going to say j, and we're going to say it starts at 0 and it goes to 5. And then all you have to do here is replace the i's in here. You just replace the i's with the j plus 1. So now it's going to be negative 1, instead of to the I power, right, the ith power, we're going to say to the j plus 1. And then here, instead of I squared, we're going to put it in parentheses and say j plus 1 squared. Okay? And so you can also check to see if these have the same 6 terms, but they should. So again, we can do that. Maybe back on this one, if we wanted to change this, again, we could come up with a different index. Maybe say, you know, I. We could change this to I and make it start at 1 instead. Okay? And so you could do that same thing and again rewrite that, like I was saying, a little bit differently. Okay, so if n starts at 2, then I plus 1, if I is supposed to start at 1, 1 plus 1 does equal 2. So you could set this n equal to I plus 1, and you could change this one. So if we did that, what would it be? So now we'd be going from 1 to 49. So we'd say that's I equals 1, and then it would be going to 49. And then in here, we would just change, instead of the n, we'll change them to I plus 1. So you could say negative 1 to the I plus 1 over, and then say I plus 1 on the bottom. So I hope this is helpful. This should help you do the rest of these problems, and I'll see you on the next video.